Good morning, dear students. Welcome back. Today we are going to discuss the last section of our chapter, problem section in the circular motion, uniform circular motion. So here we already studied the equation for speed in a uniform circular motion. V is equal to distance by time. The distance in a circular motion is the circumference of a circle. If it is a circle, the distance covered by an object will be 2 pi r. Therefore, speed is equal to 2 pi r divided by t. That is distance by time, this equation of speed itself. So, about that one, we have two problems here. One of the problem I will give you as homework. It's only this much problem discussed here in the textbook itself. And we can collect more problems at the time of revisions also. Okay. So there is only 3 model related to this one. Okay. So if you are thorough with these 3 questions, you can do every questions in this section. So to the first question. A cyclist goes once round a circular track of diameter 105 meter. So a cyclist, he goes once round a circular track of diameter 105. The diameter is 105, the radius will be 105 divided by 2. Divided by 2, isn't it? Full diameter is 105. In 44 seconds, so he takes 44 seconds for completing this. Calculate his speed. We know the equation of speed is equal to V is equal to 2 pi r divided by t, where t is equal to 44 seconds. 44 seconds. Then radius is equal to 105 divided by 2. It's in meter itself, so no problem, we need not convert. Let's write as it is. Now let's substitute these values in the equation of V. Therefore V is equal to 2 into pi, instead of pi 22 by 7, into radius is 105 divided by 2. 105 divided by 2, then divided by t. So we can add here, divided by t. What is t? Okay, it's 44. 44. So in the denominator it comes 44 into 7 into 2. The numerator is 2 into 22 into 105. Let's cancel some of the terms. 2 and 2 can be cancelled. Okay, the rest of the term 44 and 22 can also be cancelled. So it becomes here the half. How many 22s in 44? It's 2 22s. 2 22s in 44 and 1 22 in 22. So we can cancel it as 2. Now 7 and 105. Can we cancel 7 and 105? Let us check. Can we cancel or not? So let me divide 105 by 7. 1 7 is 7, 35, then 5 7s are 35. So it is 15. 15. So let me cancel this as 15 and here 1. So it becomes 15 divided by 2, which is equal to 7.5 meter per second. So the cyclist is going with a speed 7.5 meter per second. Okay, is it clear? We cancel 2 and 2, 22 and 44. The remaining is 2 here. We cancel 105 and 7. How many 7s? 15 7s are in 105. So it becomes 15 by 2, that's equal to 7.5 meter per second. Half of 15, 7.5 meter per second. Right. Is that clear? Let's move to the second question. Here, it's a logical question. This type of questions you can expect. So I will be giving an idea to do this type of questions. So this is based on the clock, that is clock or watch. The length of second hand of a giant clock is 252 cm. Calculate its speed. See, if any question regarding the clock and the length of minute hand or second hand is given, That length is actually the radius of this circular object, that is 252 is given there. So it's actually 252 centimeter. That is the radius of the clock itself. The length of second hand or minute hand is the radius of the clock. So from that you get one information, radius. And one more thing you know, to complete one revolution, how much time it takes to complete one round? If it is second hand, it takes 60 seconds. If it is minute hand, it takes 60 minutes. 60 minutes means 60 minutes is converted into second by every minute consists of 60 seconds. So 60 into 60 which is equal to 3600 seconds. So if it is minute hand, it takes a time 3600 seconds. If it is second hand, it takes just 60 seconds to complete one revolution. So it is minute hand, and if it is second hand, it takes 60 seconds. Don't forget this logic while you are doing this type of problems. Now moving to our question. So here is the question, the length of the second hand. So it is second hand, hence time is equal to 60 seconds. We know it takes 60 seconds to complete one round. Is 252 centimeter, radius equal to 252 centimeter. Is given in centimeters. So let us write it as in centimeters itself. Calculate its speed. So this is the question. So from here itself, if you need, you can convert the centimeter into meter, or if you write it in centimeter per second also, no problems. Okay, as it is uniform circular motion. So and at last also we can convert this centimeter into meter. So let's forward. V is equal to 2 pi r divided by t. It's equal to 2 into pi. It's 22 by 7. 22 by 7 into radius 252 centimeter divided by t. How much is t? Okay, it is 60 seconds. So this is our substitutions. We finished our substitution. Now let us cancel the terms one by one. We can check. The 60 and 2 can be cancelled, isn't it? It becomes 1 here and 30 here. Now can we cancel it again? Yes, one more cancellation is here. 30 and 22 can be cancelled. It becomes 11 here. It becomes 15 here. Now let's check. Can we cancel 252 and 7? 252 divided by 7, 3 7 gives 21, then 42, 6 into 7 gives 42, right? So it is 36 here, it's 1 here. So we can cancel again, 36 and 15 can be cancelled. So it becomes how many 3's? 11, 12 3's are there, isn't it? 10 3's 30, 11 3's 33, 12 3's are 36. How many 3's here? 5 3's. So it becomes 11 into 12 divided by 5. Let's do that. What is 12 into 11? 12 into 11. Let's do 2, 1, 12, 2, 3, 1. 132 divided by 5. It becomes 132 divided by 5. Now let us divide 132 by 5. How many 2 5's are 10? Then remaining is 3 2, then 6 5's are 30, 6 5's are 30, remaining is 2. Let's make it 20. 4 into 5, 20. So it is 26.4 centimeter per second, or see, it is 26.4 centimeter per second. So if you done this by changing it into meter, we'll get an answer. So if we are changing the centimeter into meter, how much centimeter is 1 meter? 100. So we have to divide it by 100. So maybe you have done by changing into 100, or we can change from here also by dividing it by 100. So if we divide this by 100, we will get 26.4 divided by 100 means this decimal point will change here, 0.264 meter per second. So here we have the answer in centimeter per second and meter per second. Okay, how we converted? Just divide by 100. That's enough, because our equation is very straight. Here R is here, we can divide it by 100 here itself. That is 26.4 divided by 100, which gives us 0.264 meter per second. Or if you get 26.4, you have to write centimeter per second. If you get 0.264, it will be in meter per second. Both answers are correct, but you can't write 26.4 meter per second. You have to write 26.4 centimeter per second itself. Then your answer will be correct only. Okay, that's all about the section uniform circular motion. The problems related to this, there are just two types of problems. One type, as I told, the circular track or circular object will be given, its radius will be given. You will be asked to find the speed. The next one is you will be asked to find the speed of second hand or minute hand of a clock. That also you know the logic. If it is second hand, it takes 60 seconds to complete one rotation, and if it is minute hand, it takes 3600 seconds to complete one revolution. Okay, hope it is fine, it's clear. Let me stop here. I will be giving a homework question with similar way of doing. Okay, you can complete it. Okay, thank you for watching. Have a good day.